Okay, so welcome to the Smart Alarm. Here's what you're in for. Like I just said, three major parts plus my introduction. So about me, my name is Garrett Curtis. I went to Purdue for aerospace engineering, so that thing really speaks to me. I spent a lot of time in a wind tunnel with pitot tubes trying to figure out wind speed and pressure differential. My first job was in aerospace. I was designing airplane seats, fancy business class seats like that one you see there. Yeah, me either. They don't pay us enough. But eventually, I got really focused on software and quit aerospace, and now I just do business automation software with my consulting practice, Cybernetics. So I focus on sort of full stack development, but I really like to experiment. So I've done some projects with VR, kind of getting into IoT, that kind of thing. Which brings us to today. Another cool thing, my wife and I just bought a house this year, our first house. And when I moved in, this is what we had for alarm systems. 2 alarms, neither of them worked. But it got me thinking. I've played with this kind of alarm before a lot. I know how to code it. It's pretty straightforward. These guys, SimpliSafe, it's like a wireless version that's all on the web and stuff. Sounds cool, but turns out they really don't like you using their stuff unless you're paying them every month to use it. Oh well. So I set out for a new project to sort of make this IoT-able. So my goal was to be able to arm, disarm, and see the status of my home alarm on my phone. Now, if you're familiar with this stuff, a couple companies in the area have sort of phone apps that you can get where you can arm, disarm, see the status. If it goes off, it'll let you know. But it's not cheap. I mean, you have to pay for that. Of course, you're also getting things like monitoring. So if the alarm goes off, they'll call the cops. My system won't do that yet. But I mean, you can see the prices there. $35 a month is pretty average. SimpliSafe is a little cheaper. I'll give it them for $25 a month, but still more than I wanted to spend. Also, I wanted to reuse my existing system rather than buy a bunch of hardware. So I started doing some research on the hardware. Turns out there's 2 major alarm vendors out there. So we've got DSC and Ademco. This is owned by Tyco Products. You guys probably heard about them. Ademco is owned by Honeywell. There's a third system, a GE system, but I don't think many people have that one. Anybody ever have a GE alarm system? Great. How about DSC? Ademco? Honeywell? Couple? All right, so about even split on those 2. Not surprised. I've had a lot of these in my apartments and stuff. Right now I have an Ademco system, which is what I have here for you too. So let's talk about what this system looks like. It's complicated. I'll walk you through it. So this is the controller box. You can see it there. This is basically the brains of the system. Everything connects through this controller box. It handles what your codes are supposed to be, what each device is, and that kind of thing. Lots of I/O along the bottom, which you can see all wired up. Typically, these alarm systems are wired. So the blue system here is sort of my wired system. You can have keypads on there, magnetic switches, motion detectors, all that junk. But I guess somewhere along the line, they decided we should do some wireless too. So rather than updating the controller, they made a new keypad with a transceiver on it so that it can talk to the rest of your wireless system. So from that transceiver, you can have all sorts of other stuff, including like, remote control, arm, disarm, like your car has. And they're basically addressable, so you can have up to 99 devices, which is a lot, really. All sorts of stuff. They have signal repeaters. It's kind of like a mesh network, some sort of serial protocol at 345 megahertz. And then finally, the red system here is sort of your phone home system. Out of the box, you can connect that to your phone line and have it set up to dial a number when the alarm goes off, which is how those monitoring services work. I guess they take that number and connect it to an operator. I don't know. But you can also buy a kit to make it online. So you can have it call the internet via a cell phone on GSM or through IP. So that's promising, but I haven't done too much work there. So when I was looking at it, I was trying to figure out, how do I get into the system? And there's basically 3 major ways. We could do the wireless, we could go for the wired, or we could try to do the phone home system. I didn't really want to touch this because if I do want to get monitoring, I don't want to have the cops show up at my door because I accidentally called home. So that kind of leaves 2 systems. Wireless is pretty cool. It doesn't seem like it's encrypted at all. You could design some sort of device to connect if you had the radio and stuff. The blue system is, for the keypads, it's a RS-485 protocol, addressable, pretty straightforward, but both Honeywell and DSC have a proprietary communication standard. So there's some people out there who sort of reverse engineered it, but not super easy for what we're trying to do. So after some research, turns out the best option is to go for the brains. So these systems have a lot of peripherals. There's a couple there, but like there's probably 50 different things you can hook to the system. And one of these is a key switch, which looks like this. And if you're using an alarm in a sort of store setting or something, rather than having your employees type in a code, you can give them a key to arm and disarm the alarm. All it is just a momentary switch that tells the box, hey, you're supposed to arm now, hey, you're supposed to disarm now. So if we had gone with the keypad route, you'd have to have your device send the code to the brains every time you wanted it to unlock the alarm. This way, it's just a switch, and the alarm says, okay, must be a key there, we're good to go. Additionally, you get two LEDs, which kind of mimic the LEDs on the keypad too. So there's a green one when the system's ready to go, and there's a red one when the system's armed. So with that, you can know what the status of the system is. So once you set your box up to use a key switch, and then you set up the outputs to use the LEDs for armed and disarmed, which you can do with the instructions. It's all written in the installer manual. It's really easy to do. You're basically good to go. You just have to design your device to handle this key switch. So that's the end of the sort of home alarm thing. We're going to go into the IoT side of things. Any questions on the home alarm thing?
Okay, so to be clear, it's two outputs from your controller to this input on the controller board.
Right, yeah. So the key switch actually has a tamper switch as well, so they can tell if you open the cover up. So that's technically two zones on the controller. You've got one for the tamper and one for the key. I don't have the tamper switch, whatever. So I really just have one zone that you dedicate to a key switch input, and it's just looking for that momentary connection to either arm or disarm the system.
Does the Particle have an electrically compatible output, or is that coming up?
Coming up.
Okay.
No, it doesn't. That's a little tricky.
Please stay tuned.
Please stay tuned. Okay, so we've got the alarm system now. The next step is sort of the IoT side of things. Again, I want low cost. I also want it to be really easy to use. Did some research. I've done stuff with Raspberry Pi. I've done stuff with ESP8266. Both good options, both inexpensive, both kind of a pain when you're trying to like actually program them because you have to plug something into it. Maybe Raspberry Pi you could get away with like a sort of remote update firmware feature. But Particle has a really nice sort of tech stack that lets you do all the administration from your computer. You don't ever have to plug anything in after you originally set the device up to link to your Particle account. So I'll let you guys read what the Particle marketing material here is. But basically they provide you a full vertical on IoT. They have hardware, firmware, a cloud solution, APIs to sort of connect to your front end, whatever that may be. I really, really like them. They give you, I think, 100 devices free right now. I'm not sure for the cloud. And then if you go over that, you start to pay per device. But we'll talk a little bit about what they do here. So they're full vertical, I guess you could say. They have two major hardware platforms. One just came out today, so it's not on here yet. But for Wi-Fi development, they have a thing called the Photon, which is pretty tiny. There's a Photon. It's really small, which is nice, about the size of an ESP8266, maybe a little shorter than the ESP8266. This is the dev board, and then they also have a surface mount integratable version if you want to put this on your own hardware or your own circuit board. And then on the cellular side, they have a slightly bigger thing called an Electron, which has 2G or 3G radio. But this is being replaced with something called Boron, which has an LTE radio as well as Bluetooth. So I should probably update this slide, but if you're into like sort of mobile stuff, that's a really good way to do it. I think their plans start at first 3 months of data for free, and then it's $3 per device per month, and you get like 3 megabytes of data transfer. So should be enough for most IoT solutions, but something to look at for sure. So once you've got your hardware figured out, then it's time to talk about the rest of the system. Particle has a thing called Device OS, which is basically a firmware that runs on the hardware, and it is what connects to the cloud. It provides encryption. It lets you do that remote firmware update thing that I talked about. So that's pretty cool. It's also open source. You can port that to other platforms. Originally, they had this running on Raspberry Pi, but that's sort of depreciated now. I've seen some other projects to move that to other hardware. So if you're really into sort of compiling things, you could probably compile device OS to run on anything. And then once you've done that, it can talk to the cloud. And then the cloud is kind of like your Azure IoT Hub or whatever Amazon and Google's solutions are. But it basically manages your devices, handles communication, and things like that. And then finally, this cloud has some really nice API features to connect to your front end, whether it be a phone app, Windows app, just a web app. They've got REST APIs. So that's sort of the whole Particle ecosystem. The way that it communicates is a little different than what you may be used to before. It uses something called COAP, or Constrained Action Protocol, which is an alternative to MQTT, which is what most people use for talking to embedded devices like this. So like MQTT, it is optimized for IoT, really low overhead, small messages. Unlike MQTT, it's meant for peer-to-peer communication. So MQTT is really designed to go from a bunch of devices into a server and then out, whereas COAP is really meant for sort of peer-to-peer. If I have a device over there and I want to talk to a device over here, I can do that with COAP, because every COAP device has to respond to basic HTML requests, so put, get, post, that kind of thing. That said, Particle wants you to use their cloud. So their peer-to-peer solution is device to cloud. So it actually acts a lot like your MQTT devices that you might be using on IoT Hub and things like that, with a few exceptions. One of the cool things it does is RSA encryption, so it is fully encrypted. If you were packet logging or something, you wouldn't be able to hijack the device or trick the cloud into thinking you had an extra device. And then it uses a TCP connection, so it's pretty straightforward. It's tunneling, so if you had your device behind like a corporate firewall or something, or even if you shipped it to a customer and they didn't know anything about NAT, it could tunnel through and get to the cloud as long as it can get to the internet. So that's nice. Okay, so we've covered the whole architecture. Let's talk about, as developers, what we do with the Particle. So the first sort of cloud communication option is the variable. Basically, you initialize a variable in startup, and then you tell it what the variable is supposed to be. Unlike things like Azure IoT Hub, it doesn't send the variable back to the server. You have to request it. So when you do an HTTP or a request to get that variable name, you request to the cloud, and their cloud peer-to-peers down to the device and asks you what the value of that variable is, and it sends it back to you in the response to the request. So it's not logging everything as you go. It's just sort of telling you, hey, I have a value you could read, and then when I get this request, I'll go ping the device and see what the value is. So I guess that's one way they save data, is that they only send the data when you request it. The next option is function. This should be pretty similar if you're used to these IoT things. You declare a function, and then you can call the function with your API by passing the device ID and the access token. It's OAuth based. And then you can add an argument. So here we've got a function to brew coffee, which basically just is calling the brew function, and then we're passing the coffee argument. And then, in the string, or in the function, it takes that string as an input, and you can do whatever logic you have to do on that function. But again, the main flow is you sort of declare this function exists, and then the cloud knows about it, and then you can call that function from an API endpoint from your device. Okay, here's where it starts to get interesting. Publish is basically a way to send updates to the server automatically from your device. So unlike the variable, you don't have to declare anything. You just call publish, you give it a name of what event happened, and then you can tack on a string value as a payload. And then in the cloud, you've got all your events and then the data, which is a string value. And you can do whatever you want with them. However, Particle doesn't save any of this. You got about 60 seconds to handle this before it's gone forever. But they have a ton of links. So you can link it to Azure, link it to Google, link it to Amazon, save it in storage there, use webhooks to sort of talk to other things when certain events happen. So if you wanted to fire off an if this then that thing to Google Home when an event happens, totally doable with these publish events. Okay, the last thing is what really makes this a cloud. So you've got this device publishing events to your cloud. You can actually subscribe to those events with another device, and whenever that event happens by name, the device says, okay, I'm looking for that event. I'm going to call this callback function and do something with it. However, by default, if you don't tell it anything, you're subscribing to the public cloud. Every particle device out there publishing events, you can get them. Or you can constrain it to just my devices on my account, or you can constrain it to a certain device ID. So if you really wanted that device's events, you could do that. Recently in May, they decided that that Firehose API endpoint, which is just public all events, was too big, so that's gone. Now you have to call that with a prefix. So if you want to prefix all your devices a certain way, you can use that to sort of segregate your data from the public cloud. But know that if you're publishing to the public cloud, anybody can get those results. So it's really a device cloud, and you can do some pretty cool things. I haven't used this very much because I don't have very many devices. But theoretically, what you could do is have a device on a motion sensor. When you see somebody move by, it publishes motion detected, and then another device listening for that turns the lights on when motion's detected. So that's an example of how you could use publish and subscribe to sort of build a cloud of things. If all this is a bit too much for you, they also have a very nice mobile app called Tinker, where you basically just pick your device, and then you've got all your I/O there. You can pick it and say, all right, this is a read, this is a write, set value 1, set value low, and then you can just sort of immediately tinker with your particle device. You can't do any functions or anything here, but it's a really nice way to sort of mess around and get started, get your feet wet, especially if you don't like programming. It's okay. You can play around with it. Okay, live demos next. Any questions about that section? Cool. All right. So, like I said, I hope this works. Okay, so here's my solution to this problem. It's basically that whole alarm system you just saw. I can arm it. 1, 2, 3, 4. Here we are. Dun, dun, dun. I disconnected the motion sensor because it was too sensitive. But I could open the door and set the alarm off. Okay, and then here is my solution to the connectivity thing. It's not very pretty, but you know what? It works. So to answer your question, this whole system runs on 12 volts with a battery. There's an AC to 12 volt thing that they give you when you buy the system. So these particles take 5 volts, so you have to sort of step that down somehow. I had something I bought on Amazon. It's like a very low voltage converter, but there's dedicated circuits for 12 to 5 volts. I just don't know what they're called. So I have a couple of relays set up here. I don't have the circuit diagram, but if you know anything about this stuff, you can probably figure it out in your head. But basically, the particle is switching at about 3 volts, and so it steps it up to a relay to 12 volts, and that's enough for the system to realize something's happening. Likewise, for the LEDs, when they come out of the system, they go through a few relays to step it down to 3 volts. That is one of the two. So enough that the board won't be fried when the LEDs turn on. Okay, so let's see. The next thing I need to do is find a phone. Right now the particle is blinking green, which means it doesn't have Wi-Fi. So let me turn on the Wi-Fi. Tethering, Wi-Fi hotspot, turn on. I set this up to use my hotspot so I could do it on the go. So this should shortly, there we go, and turn blue. Yep, okay, we're online. That was easy. So let me, I guess, start with the particle console. Where is the other screen? That was really small. Okay, so here's my particle console. Basically, it's an overview of my particle instance. I'm just a DIY guy, but if you wanted to make a product and sell it to people, you can segregate devices by things that I own versus things I've sold to people and are using my software and hardware, so I need to sort of track them and be able to see how they're doing. And you can segregate security that way too. So if you sell something to somebody, they can log in and see their device, but not everybody else's devices that you sold to. And it's all done through this particle console. So my device, if I refresh this, at 5, not at 4, well, not the fastest. Yeah, there we go. Okay, so now it's online, my demo alarm device. If I click on that device ID, it takes me to sort of a dashboard for that particular device. Some stats here, tells me how long it takes to get to the device. There's been a disconnect event because I turned the internet off on it. If I had logs, which I don't for this thing, it would see all the events happening, like I told you earlier. And then down here are sort of the functions and variables that I defined for this script. So like I said, it doesn't tell you what the value of the variables are until you request them. So if I get the value of the red LED and the green LED, red LED is off, green LED is on, check, we're good. This function is how I set the whole thing up. So if I set that to stay, it should send it to the device and arm my alarm. And then if I set that to disarm, you can see I've got an integer here. It's returning from the function call, which is a feature of the functions. I think disarm should return a 0. A 1, fine. Away is good, except I only have 5 seconds. I gotta open the door if I'm gonna leave the house. Nobody move. I'll set the alarm off. Okay, and I won't set it off on your poor ears here. Disarm. Oh yeah, I guess I should test the LEDs too. So now that the alarm is set, red is on, green is off, as you can see there. Boom, there we go. Cool. All right, I have a few minutes left, right? So let me take you through what this looks like as far as coding the device. If we go to the particle build interface, unlike the console interface, this is where you actually do your coding and managing devices and things. So here I've got this app called Alarm App. Got a couple other apps as well, not with much in them. But if you're used to doing anything with C and Arduino, it's the same language. So up here I basically set what pins do what. In the setup function, I've got those, it's probably pretty small for you guys, but I've got the function declaration there, which was set status, and I've got 2 variables, red LED and green LED. So setting them here caused them to show up in the particle console. And then I set the pin modes for the device. I do some flashing with the LED to let me know it's connected. And then I just have a loop that basically checks the status of the LEDs and writes them to the variable. And then when that request gets called, it sends the current result out to the web. And then my function declaration called a function called setStatus, which is down here, which basically is looking for disarm, stay, or away. And based on what it gets, it checks to make sure it's not armed. And if it's armed, it disarms it, and then it sets whatever status I asked it to set, which is basically just a bunch of close the switch, open the switch. So stay is a 4-second hold and then off. Away is a 1-second hold and then off. And then disarm is, if it's armed at all, just a 1-second hold and then off, and it disarms the system. And that's all it took. So if I wanted to make a change to this, if I was using 8266 or something, I'd have to make a change, compile it, connect the device, upload the firmware change. Here, I guess I could just do something along the lines of, let's see, in my disarm function, I'll return a 5. Oh, that was fun. Instead of a 1. Okay, so now that I've made a change here, I basically hit save, verify, it compiles on the web, and then make sure there's no issues with my code. Code verified, great work. Thanks, device. And then I just did flash to send it to the device, but first I should probably check what devices we have. So I have 2 devices. I'm going to send it to demo alarm, not sandbox. If I wanted to, I could update the firmware here too. So version 8 is in, or 0.8 is in a pre-release, but it gives me some extra features. Basically, I just tell it which device to send it to and then flash. And so it's getting the new changes now, updating the firmware. It should take a little bit to do that. Or maybe my phone turned off and it's offline with the green flashing. Let's see. Yep, that's what happened. Cool. So it's still flashing code, but the device went offline. It should come back on here in a second and then finish flashing the code. And there's some nice fallbacks too. So if it like errors out halfway through, it won't brick the device. It just goes back to the previous firmware. Flash unsuccessful. Well, this Prez was offline. Let me try that again. Flash. Okay. It should turn purple. Yep, there we go, which is the flashing color. And then it will turn off again.
Is there a way to queue a flash? Like, say I've got 50 devices, just whenever they show up, flash it?
I don't know. That's a good question. I'd have to imagine that's possible. basic IoT stuff. But now that that's set, I should be able to call disarm and get a 5 back. How about that? Boom, no plugging anything in. So that's why I really love these particle devices, because it's so easy to manage them. Okay, that's it. Any questions? Yeah.
Show the loop.
Yeah, sure.
What's in it? Like what does that do?
The loop is just basically doing digital reads on the pins to get the current LED status.
Yeah, the idea is that it runs set up once, then it runs a loop forever.
Yeah.
So
How frequently does it run?
And
as fast as
Yeah.
it can.
it's probably best to put a delay in here. I built a device once to go in my car on an infinite loop, and it drained the battery in like a week. I took a flight and couldn't get back. But I put some stuff in so it would go into low power mode in between cycles and like had a 2-minute cycle. It's been fine since then. So if you're worried about battery life, put some delays in there. I know Arduino-based things can go into a low power mode. I have to assume these guys can do the same thing. I haven't done it before, but yeah.
What is Sandbox?
That's my other device. Which
So it's a real physical device?
Yeah.
Okay.
Yeah. Yeah, probably you could, I think you have to have a real device to like really do anything here. I think it's offline. Yeah, it's offline. But
That's set up to shock the cats when they get in the sandbox.
yeah, I put the pitot tube on them, and if they go too fast, it shocks them too. No running in the house.
Question.
Yeah.
Back to your code for a second, there's one thing I thought I didn't understand. There's like a flash something down to the,
Oh yeah, so this
yeah, and
just,
each of those you've got like a flash board.
yeah, so this is when the power comes on the device. There's a RGB LED on the board, and so it, no, this is the pin 7. There's 2 LEDs. There's a RGB LED for like device status, so that was the one that was turning purple and green and stuff.
Oh, I see, you're actually flashing, I thought you were flashing the firmware.
No,
Not
no,
flashing
just
the
flashing
LED. Particle flashing.
even though it's called flashboard, it's just the LED. Yeah, there's another LED on pin 7 or something, which you can use to just do diagnostics, which is what this is doing. Flashes at me and let me know it's started. I think you can control the RGB LED as well. I haven't done much with that, but yeah. So the internet button is a pretty cool thing. Basically, it's just a little housing for the thing, but you can click it, and it clicks one of the onboard buttons. And I'm pretty sure if you got the LED, you could the button would light up nicely and show you a certain color. So yeah, it's cute. And then this thing is just a maker kit. It also includes a photon, but with a breadboard and some pins and I don't know, other stuff that you can use to start your very own particle project.
How do you check if this is tripped?
So I don't want to set it off here. But basically, when the system's tripped, red LED goes from standby to flashing.
Oh.
So you could use that. I don't have it coded in.
Monitor them.
Yeah, I mean, you probably put something in the loop to see, check it every whatever, and if it's changing.
You can publish that back out to.
Yeah, what I really should do here is set up publishes for every LED event change, because that would let me know something's going on with the system. And then I could subscribe to that with some other thing. Chain things together. Yeah.
So just to recap, when you send a signal, either ARM or disarm, it goes to the photon device.
Yep.
And then the photon device sends a signal to the brain.
Yeah, it just closes the switch.
All right, so it simulates
The key
switch,
turning, yep.
And then that sends it over to the actual panel that changes the switch, the light from green to red.
Yeah, so technically the panel's really dumb. It doesn't do anything.
Right.
It has a 4-line serial interface that goes back to here. And so when you type your code in and hit ARM, it's just sending those numbers and then ARM, and then this thing is doing all the processing. So since I'm hooked up directly to this thing, it knows this zone is a key switch zone, and when it sees a close, it knows it has to ARM or disarm with no code.
And that's a lot easier than reverse engineering the code.
Yes, and so I have some slides on that actually too, because I figured you guys would ask. So next steps, RS-485, really open standard. It's just serial. I forget the details. There's 2 people who have really done a lot of work on this. One of them is this home security GitHub. They've got it reverse engineered enough for an Arduino to read the data. They don't have any sort of writing stuff. But other projects have taken this guy's work and sort of built on that. I know that there's at least one ESP8266 solution, sort of redeploying this package. And then there's a company called Alarm Decoder who's done all the work, and they will sell you a module that can talk to a Demco, a DSC, whatever, with the serial connection. So if you really wanted to get fancy with it, they've got that. And that connects through serial to other devices or USB, I think are the two options that they're selling right now. Of course, this was all with the particle thing, but I should make a front end for me with authorization and stuff. Of course, they've got a lot of APIs. You saw some of them there in my slides, but to talk
You
to
all
the
have
guys.
1, 2, 3, 4 code too, I think.
Yeah, not a bad idea. No, but that's like, if they've got to the panel,
Oh, yeah.
it's
So,
way too late.
If you lose business security, you have no.
Yeah,
no
exactly.
convenience, right? If I can reboot your machine.
Yeah, it
Your
does.
house and figure out the part started to run.
Yeah, there you go. That's
Not in real life.
So you show like setting up the alarm, disarming,
Yeah.
away, and all that stuff. So how do you get the signal that something happened? Like notice the door.
So you don't have very much to play with, especially with the Demco system. You basically just have those two output LEDs. I haven't played with the whole system yet, but there's basically 8 pins here in the header that are for output, and so you can set up sort of basic logic things. So if this zone gets tripped, output high to this pin. And so you could go in there and really program sort of, if you had a few things you wanted to track, you could get those output pins to go high or low based on different events.
That way you could identify the window was open,
Right.
the door.
It's really a lot of time on your hands. You might could sniff the RF side too. And I don't know what they have in 345, but all the wireless weather sensors you can get, there's an SDR program for that that will decode your AccuRite temperature and all that kind of stuff. So I'm sure somebody's done 345.
I saw one project on 345 for the Demco stuff specifically. But yeah, so if you really want to know exactly what was going on, the keypad will tell you sort of what zone's open and that kind of thing. So you have to get into the serial bus somehow. Then you'd be getting all the messages basically.
So, but right now, when you're doing it, you're checking if it's red or it's green.
Yeah.
If it's red, something bad happened.
Or it's armed.
Oh, it's on.
Yeah, if I set the alarm off, it'll flash red,
Yeah.
and so that's what you can do.
I love the simplicity of that. Yeah, there's a lot of
So easy.
So easy.
So somebody asked, oh, what this thing has a key? Oh, hey.
Oh hey.
Was it fun testing this?
Yeah, so
That's-
I built this last night. This was about less than $200 on Amazon to get the whole system, so you can set one up in your house pretty easily. My wife was not happy because this the same one we have at home, right? So every time I beep, she was like, "Oh, what's going on?" And the alarm would go off. Yeah, it was really fun.
So, how many pins are on the photon?
That was the easiest way to answer that. Let me go back to that slide about 1, 2, 3, 4, 5, 6, 7, 15 total. I think I have 8 digital and 6 analog.
You may only
Couple
use
others.
analog as digital sometimes.
Yeah, I think some of them go versus way. I think D you can use as A, and then there's like one SPI, one UART thing. So it's a lot like the Arduino. If you're used to using one of those, you get the same functions.
The software looks extremely simple.
Yeah.
Only the units there.
Yeah.
Libraries.
And when you're communicating to it from your phone, you're using the Tinker app.
No, you can't do much with that. So with the app, you could do the same thing I was doing online with the registered functions variables. You can see the statuses. You can send it a new function value, so like arm or disarm. So yeah, you could use the app. It's probably better to write your own web app and use the
Right.
API.
Okay, good. That's where I was going.
Yeah, that's their preferred thing too. They want you to sort of use all these APIs they've got and write your own solution
All right.
for that. But it also links up to Azure IoT Hub too. So you can set a particle up, you can manage it with the particle stuff I showed you, and then use the Azure Hub to do follow-on functions and things if you already have an ecosystem built there. Same with Amazon and Google. I don't know what their products are called, but it works there too.
How much are those devices?
$20, $19, but I can't find it for less than 20 for the particle, and then the wireless one is $50 plus that $3 a month subscription for the service.
But they're all wireless. You need them more than modem.
I mean, the cellular device.
Cellular.
Yeah. So not too bad. And then I think it's cheaper if you don't get the dev board, or if you buy in volume, it's cheaper as well. You know, that service mount version is less expensive. Cool. And I got to say, they're really nice to send us some stuff. If you have a club that you're part of or something, you can go register and they'll send you this kit as well, so you can sort of get your club started with Particle.